Okay, on this video here, again, this is Mr. S talking to you about verifying this trig identities. Okay, you have seen one example of the use of sine square plus cosine square equals 1. You're going to see another type of usage for that Pythagorean theorem. But before that, here's what I need to do. I have to say, well, I will try to work with this side. So you have to work through the most complicated part to make it look like cosine to the third power. So this here is about factoring. For those of you guys that are still struggling with the factoring, this is not for you. Then you have to review the factoring. So if you have cosine like this, it's like if you have 3 times 1 plus 3 times 4, right? You can just pull out the 3 and keep 1 3, right? Not 2 of those, not square. You add the 1 and the 4 first. So 1 plus 4 is 5, 3 times 5 is 15. As you would have done here, 3 times 1 is 3, 3 times 4 is 12, 12 plus 3 is 15. Make sense? Okay, so you probably didn't see the whole thing, but it's okay. Okay, so we're going to use the same technique, factoring. Now there's no 1 behind the cosine here. I'm going to have to make a 1 behind it right there. So now I'm going to factor the cosine from that. So you're going to get cosine of x. I won't write the x, I'll just write cosine. And then 1, there's 1, this red one here, minus, since I took the cosine away from the sine square, it's 1 minus sine square. Okay, now I'm trying to get here. According to the Pythagorean theorem, it's cosine square plus sine square equals 1. Now if I take this sine square and subtract this way, or subtract sine square from both sides, 1 cosine square equals 1 minus sine square, or 1 minus sine square equals a cosine square. So that is a fair trade. So I can trade this with a cosine square. And then in the front, I already have another cosine to multiply. So now you got a cosine times a cosine square, you'll get cosine with the third power. So that should equal to the right side, which already waited for you. It's been sitting there for a while. Okay, that's a 3-minute one.